How's it going? It is me, Citrus. We are back learning C sharp. So today I'm going to do this entire unit. It's going to be store and retrieve data using literal and variable values in C sharp. So I'm going to start the music and then we're just going to go. We're doing Zelda music again, by the way. Many of the applications that you'll build in C sharp will require you to work with data. Sometimes that data will be hard-coded in your application. Hard-coded values are values that are constant and unchanged throughout the execution of the program. Hard-coded values are values that are consistent, or hard-coded values are values that are constant and unchanged throughout the execution of the program. For example, you may need to print a message to the user when some operation succeeds. A success message would likely be the same every time the application is executed. This hard-coded value can also be called a constant or a literal value. Suppose you want to display a formatted message to the end user containing different types of data. Suppose you want to display a formatted message to the end user containing different types of data. The message would include hard-coded strings combined with information your app collects from the user. I'm like finding myself reading everything twice. The message would include hard-coded strings combined with information your app collects from the user. To display a formatted message, you'll need to create both hard-coded values and define variables that can store data of a certain type, whether numeric, alphanumeric, and so on. In this module, you create literal values that contain different data types. You'll create variables that can hold certain data types. Set those variables with a value, then retrieve those values later in code. And finally, you'll learn how you can simplify your code by allowing the computer to shoulder some of the work. By the end of this module, you'll be able to create literal values and store and retrieve data in variables. In this module, you will create literal values for 5 basic data types, declare and initialize variables, retrieve and set values in variables, allow the compiler to determine the data type for your variable when initializing. Must understand basic C# syntax rules. Must understand how to use console.writeline. Beginner level experience with .NET editor. Can we just pretend that I do? Let's go over what we learned yesterday. So, console is a class. The dot is the member access operator. WriteLine is the method, and it has parentheses, and then the semicolon is the end of statement operator. Makes sense? All right. I think this is the next step for me. I hope it is. I think it is. Print literal values. In this exercise, you'll print messages containing other types of data and learn why data types are so important in C#. What is a literal value? A literal value is a constant value that never changes. Previously, you displayed a literal string to the output console. In other words, you literally wanted the string. Dude, we're saying literally and literal so much, and I will stutter saying that too many times. I promise you I will. In other words, you literally wanted the string of alphanumeric numbers, HELLO, and so on, displayed in the output console. Use the string data type whenever you have alphanumeric words, phrases, or data for presentation, not calculation. What other kinds of literal data can you print to output? Print different literal data types. There are many data types in C#, but as you're getting started, you only need to know about 5 or 6 data types since they cover most scenarios. I like that. Let's display a literal instance of data to output. A C# code editor is available to use. Oh yeah, I already have that. Already got that. Use character literals. If you only wanted a single alphanumeric character printed on screen, you can create a char literal by surrounding one alphanumeric number character in single quotes. The term char is short for character. In C#, this data type is officially named char, but frequently referred to as character. All right. All right, sure. Console.WriteLine. I gotta get better at typing without looking. I really do. Console WriteLine, and then just to be Did I do that without looking? Yes, sir, he does. Wait, that's not a double. That's just they did just this. What the heck is the difference? There doesn't seem to be that much of a difference. Observe the code you entered. Notice that the letter B is surrounded with single quotation marks. Single quotes create a character literal. Hold on, wait, if I do like BC, it won't work, right? So it only works with one. But if I did want B and C to work, I'd have to do this. But for only singles, I mean, you could also do that. But we're just doing one. Interesting. Okay. Single quotes creates a character literal. Recalling that using double quotation marks. Recall that using double quotation marks creates a string data type. So what we did, single quotes is character literal. Double quotation is a string data type. Okay. If you enter the following code, it won't work. Yeah. Too many characters in character literal because you need the double quotation mark. Notice the single quotation marks surrounding hello world. When you use quotation marks, the C# compiler expects a single character. However, in this case, the character literal syntax was used, but 12 words were supplied instead. Just like the string data type, you use char whenever you have a single alphanumeric character for presentation, not calculation. Use integer literals. If you want to display a numeric whole number, no fractions. Oh, brother, are we going to be doing math? I'm cooked. If you want to display a numeric whole number value in the output console, you can use int literal. The term int is short for integer, which you may recognize from studying math. Sadly, I do. In C#, this data type is officially named int, but frequently referred to as integer. An int literal requires no other operators like string or char. What? Add the following line of code in the code editor. Are the quotations an operator? And it's saying that you don't need it. That's kind of cool though. Hey. Okay. Use floating point literals. A floating point number is a character. Hold on, I'm gonna turn my air off because you guys might. I don't want it to be bad background. All right. A floating point number is a number that contains a decimal. For example, 3.14159, is that pi? Supports three data types to represent, C# supports three data types to represent decimal numbers: float, double, and decimal. Each type supports varying degrees of precision. So, float type, and then there's precision. Okay. So 6 to 9 digits, you use float. Wait, what? 15 to 17 digits, double. 28 to 29 digits, decimal. What the flippity dip does that even mean? Add the following line of code into the editor. 0.25f, what are we doing? Okay. 0.25f. Oh, it's a float. And if this was a lowercase f, it would not work because C# is case sensitive, right? Well, seems like no one cares. All right. To create a float literal, append the letter F after the number. In this context, the F is called the literal suffix. Okay. The literal suffix tells the compiler you wish to work with a value of float type. You can use either a lowercase f or an uppercase f as the literal suffix for a float. Okay. Notice that the float data is the least precise, so it's best to use this data type for fixed fractional values to avoid unexpected computation errors. It's like computer error. All right. Data type for fixed fractional values. I don't even know what that means. Add the following line code into the code editor. 2.625. I don't think it'll work. It will? Interesting. To create a double literal, just enter a decimal number. The compiler defaults to a double literal when a decimal number is entered without a literal suffix. If I put F, will it break it? No, it still worked. Interesting. So does it turn into a float or a double? Confusing, right? Okay, add the following line of code into the code editor. 12 point, what the heck are we doing? 12.39816 M. To create a decimal literal, append the letter M to the number. In this context, the M is called a literal suffix. The literal suffix tells the compiler you wish to work with a value of a decimal type. You can either use a lowercase m or an uppercase m as the literal suffix for a decimal. Float, double, decimal. I do not understand the difference right now. Yeah, I don't know the difference. To create a decimal literal, I mean, I know the difference is like you're either working with the float, double. Is it called a float literal? What? Yes, to create a float literal. So there's a float literal, double literal, or a decimal literal, right? I just don't know what the difference of them really is. All right, use Boolean literals. We are diving so deep into this now. Boolean literals, I've never even heard of that. If you wanted to print a value representing either true or false, you could use a bool literal. The term bool is short for Boolean. In C#, they're officially referred to as bool, but often developers use the term Boolean. Add the following lines of code into the editor. Remember, if you just want to ignore that, you just hit them with the double or the double slashes. All right. See, we're finally getting to the trues and the false, man. I've seen those before. I really got to get better at typing if this is like something we're gonna do. Notice how this is lowercase, by the way. I wonder if it works if you don't do it lowercase. Work smarter, not harder. You know what I mean? All right. But we just wrote true and false. Like, that's what they would see. The bool literal represents the idea of truth and falsehood. You'll use bool values extensively when you start or add decision logic to your applications. That's so awesome. You'll evaluate expressions to see whether the expression is true or false. Okay? You'll evaluate expressions. Why emphasize data types? Yeah, that does make sense. I would like to know why. This is for float, double, and decimal, right? Data types play a central role in C#. In fact, the emphasis on data types is one of the key distinguishing features of C# compared to other languages like JavaScript. The designers of C# believe they can help developers avoid common software bugs by enforcing data types. You'll see this concept unfold as you learn more about C. I'm just going to say C. Data types define capabilities. Earlier you saw strings and chars used for presentation, not calculation. If you need to perform a mathematical operation on numeric values, you should use int or decimal. If you have data that is used for presentation or text manipulation, you should use a string or char data type. Suppose you need to collect data from a user. My peripheral is looking at this bottom part. Only macaroni and cheese. Suppose you needed to collect data from a user. Sorry, I think I overreacted. All right. Suppose you needed to collect data from a user, like a phone number or postal code. Depending on the country or region where you live, that data may consist of numeric characters. However, since you rarely perform mathematical calculations on phone numbers and postal codes, you should prefer to use the string data type when working with them. The same can be said for bool. If you need to work with words true or false in your application, wait, those were not put in quotations. I just realized that. Interesting. Because if you just do like this, it won't work. That's cool. Super cool. Right. If you need to work with the words true and false in your application, you would use a string. However, if you need to work with the concept of true or false when performing an evaluation, you use a bool. Okay, so like you could say the word true, you'll just have to put in quotations, double quotations. But if you are using it like for the concept of true or falsehood, you'll use a boolean. It's important to know that these values may look like their string literal. Wait, what? It's important to know that these values may look like their string literal equivalents. In other words, you may think the statements are the same. What? So the output's going to be 1, 2, 3. So the green is what it's showing me, what the output's going to be. Okay. So that's going to have the output of 1, 2, 3 just as it's just going to be characters. And then that is going to be working with the actual numbers. Okay. Okay, I see the difference. However, it's only the displayed output that appears to be similar. The fact is that these type of things you could do with the underlying interbool will be different than their string equivalent. I kind of want to write this down in my notes. Yeah. All right. We have Boolean. We have Boolean, we have int, we have char. Boolean. Boolean. Oh yeah. All right. So, we have. What were they, like integers, like double integer, right? All right, hold on. I think I have Boolean like wrong. I know I don't know if it's just for true or false. Yeah, I don't actually know that. For outputting words, I think. So there's a float, which is F. There's double, which I don't even know, like, what, you don't even need to put anything for a double decimal. From what I know, the double, you don't even have to like use anything. And these are literals. Integer literals is what these are. Right? Character literals will be okay. Okay, I think I get it. So this singular B will just be, is there a name for that? It's just a char, right? That's a character literal, and this would be a string. Okay. Nice, bro. Really nice. No need for operators. This is so fun. I mean, I think it is. I don't know, I'm just learning something new, man. I just know it's gonna turn into something awesome one day. Alright. And then I didn't understand the precision. Dude, varying degrees of precision. Let's just put that over here. I don't know if these are like exact. I think they are. Float data type is the least precise. So if you want to get into the nitty gritty, you want to use decimal, right? I think so. Defaults to double. And the M stands for, it's a literal suffix. What? The value of a decimal type, okay. I gotta use the restroom, bro. I really do, but I'll wait. You guys like my notes? I gotta use the restroom, bro. All right. The fact is, the kind of things you could do with the underlying interval would be different than their string equivalent. That makes sense. The main takeaway is that there are many data types. We will focus on just a few for now. The string is for word phrases. Okay. Character is for single alphanumeric character. Int is for a whole number. Decimal is for a number with a fractal component. Bool is for a true or false value. I'd rather put that in my notes, honestly. All right. That makes sense. Next unit is declare variables. Okay, I'm gonna use the restroom. And I'm back. Declare variables. A literal is literally a hard-coded value. Okay, literally. Hard-coded values are values that are constant and unchanged throughout the execution of the program. However, most applications will require you to work with values that you don't know much about ahead of time. In other words, you need to work with data that comes from users, from files, or from across the network. When you need to work with data that isn't hard-coded, you'll declare a variable. A variable is a container for storing a type of value. Is a container for storing a type of value. Variables are important because their values can change or vary throughout the execution of the program. Variables can be assigned, read, changed. Use variables to store values that you intend to use in your code. A variable name is a human-friendly label that the compiler assigns to a memory address. Okay, so the variable is what contains type of value. Okay. When you want to store or change a value in that memory address or wherever you want to retrieve the stored value, you just use the variable name you created. Okay. Declare a variable. Oh, this is about to be so awesome. Alright, we'll get rid of this. Instead of deleting it, I'll just ignore it. Alright. String. First name. Okay. In this case, you're creating a new variable of type string. Wait, what? In this case, you're creating a new variable of type string called first name. From now on, this variable can only hold string values. You can choose any name as long as it adheres to a few C# syntax rules for naming variables. Variable name rules and conventions. Software developer once famously said, "The hardest part of software development is naming things. Not only does the name of a variable have to follow a certain syntax rule, it should also be used to make the code more human readable and understandable." That's a lot to ask of one line of code. Here's a few important considerations about variable names. Variable names can contain alphanumeric characters and the underscore character. Alphanumeric characters. I don't even know what that means, really. Special characters like the hash symbol, also known as the number symbol or pound symbol or dollar symbol, are not allowed. Variable names must begin with an alphabetical letter or an underscore, not a number. Variable names are case sensitive, meaning that string value and string value are two different variables. Alright. Variable names must not be a C# keyword. For example, you cannot use following variable declarations: decimal or string. Okay. There are coding conventions that help keep variables readable and easy to identify. As you develop larger applications, these coding conventions can help you keep track of variables among other text. You could just do string with 2 R's or 2 S's, right? Here are some coding conventions for variables. Variable names should use camel case. which is a type of writing that uses lowercase letter at the beginning of the first word and uppercase letter at the beginning of each subsequent word. For example, this is camel case. Wait, what? So basically, wait, what? So you're saying this is, and then what it is? Variable name should use camel case, which is a type of writing that uses lowercase lettering at the beginning of the first word and uppercase letter at the beginning of each subsequent word. Okay. Variable names should begin with an alphabetical letter. Developers use underscore for a special purpose, so try not to use that for now. Variable names should be descriptive and immutable in your app. Choose a name for your variable that represents the kind of data it will hold. Variable names should be one or more entire words appended together. Don't use contractions or abbreviations because the name of the variable and therefore its purpose may be unclear to others who are reading your code. Okay? Variable names shouldn't include the data type of the variable. You might see some advice to always use a style like string, str value. That advice is no longer current. I don't even know what that means. The example string first name allows all of these rules and conventions, assuming that you want to use this variable to store data that represents someone's first name. Okay. Here's a few examples of variable declarations that use the data types that you learned about. Okay, user option, game score, particles per million. Wait, hold on. Character user option. Oh, okay. So the character user option. So like A, B, C, or D. Integer is your score, so like 1,000. Decimal, particles per million. I don't know what you would really do with some type of decimal number though. Bool, process customer. Don't understand that one. So variables are temporary values. Before you can use a variable, you have to declare it. To declare variables, you first select the data type, the kind of data that you want to store, then give it the variable name that follows the rules. All right. All right. Sure. Now that you know how to declare a variable, let's learn how to set, retrieve, and initialize the value of a variable. Setting and getting values from variables. Because variables are temporary storage containers for data, they're meant to be written and read from. You get the chance to do both in the following exercise. Working with variables. In this exercise, you'll declare a variable, assign it a value, retrieve its value, and more. First, let's clear the code you wrote previously and create a variable. Select all the code, delete it. All right. String first name equals Bob. Okay. So string first name. Okay. And then first name equals, I wonder if it has to be a space. Probably does, yeah. Equals Bobby. Bobby. All right, we got Bobby in here. To declare a variable, you enter the data type you want to use, followed by the name of the variable. To assign a value to a variable, use the assignment operator, which is a single equals character. Okay. So the equal is the assignment operator. All right. It's not going to play anything. This is just like stored. Assigning a value is also referred to as setting the variable. Simply a set operation. Improperly assign a value to a variable. It's important to notice that assignment happens from left to right, or from right to left. In other words, C# compiler must first understand the value on the right side for the assignment operator. Then it can perform the assignment to the variable on the left side of the assignment operator. If you reverse the order, you'll confuse the C# compiler. Modify the code you wrote so it's string first name, Bob equals first name. All right. They did not like that. Now run the code, you'll see the following errors in the output console. Left-hand side must be a variable. Property or indexer. And there's one occurrence of it. Pretty cool. Improperly assigned a value of the incorrect data type to the variable. So if you put like Bob equals integer, it's not a number, so you learn that C# was designed to enforce types. When you're working with variables, enforcing types means that you can't assign a value of one data type to a variable declared to hold a different data type. Modify the code you wrote. So integer first name equals Bob. All right. So integer first name equals Bob. Now run the code. The name first name does not exist in the current context. Nice. Failed with Roslyn. Who's Roslyn? All right. Cannot implicitly convert type string to int. Well, that is not what it told me. It told me something else. All right. The error message hints that C# compiler tried to do behind the scenes. It tried to implicitly convert the string Bob into the int value. However, that is impossible. Even so, C# tried to do the conversion but failed since there's no numeric equivalent for the word Bob. You'll learn more about implicit and explicit type conversion later. For now, just remember that a variable can only hold values matching a specified data type. Retrieve a value stored in the variable. To retrieve a value from a variable, you just use the name of the variable. This example will set a variable's value, then retrieve that value and display it in the console. Modify the code you wrote to match. String first name. Okay. first name equals Bob. Console write line, first name. All right. All right, so string first name, and then first name equals, we're gonna hit it with citrus. All right. Console write line, first name. You don't even have to do any of that. Okay, well, I did something wrong. Expected one occurrence. Let me try and figure out what I did wrong without looking. Oh, I see. You gotta end that bad puppy. All right. I can see that being a problem, bro. Like, not knowing what you did wrong with your code, so you're just like, what did I do? Okay. Now run the code, you'll see the result in the output console. It's pretty awesome. We got Bob. Retrieve a value from a variable is also referred to as getting the variable. Simply a get operation. As you write lines of code, you'll see that the compiler is checking your code and spotting possible mistakes. The compiler is a great tool to help you get code correct sooner. Now that you're familiar with different data types, with different types of errors, you can quickly fix mistakes with the help of the compiler's error messages. Reassign the value of the variable. You can reuse and reassign the variable as many times as you want. This example illustrates the idea. Modify the code, so string first name equals Bob, first name equals Liam, first name equals Isabella. Okay. All right. I get it. If you want to be a real G, you just gotta do this. All right. Definitely not what I wanted. All right, first name, Citrus. Okay. First name, Bowser. Mario. Now run the code and I'll get 4 names, huh? Citrus, Bowser, Mario, Carly. Look at that. And then I assume you do this, it's just gonna keep giving you Carly, huh? Or, yeah, it will. Because Carly was the last one that you did. Nice. Initialize the variable. You must set a variable to a value before you can get the value from a variable. Otherwise, you'll see an error. Alright. So, string first name. Okay, yeah, you didn't set it. You did not set what the first name was. So it's like, what are you doing, huh? Use of uninside local variable. Okay. To avoid the possibility of an uninside local variable, it is recommended that you set the value as soon as possible after you declare it. In fact, you can perform both declaration and setting the value. of the variable in one line of code. This technique is called initializing the variable. Oh, now that's tough. Modify you code you. Oh, that's so tough. All right. So string first name equals Bobby, right? And then Bobby. Bobby, welcome. It definitely is a lot better. Kind of like that. You must set a value to a variable before you can retrieve it. Dude, I like putting these in my notes. Alright, you must set a value to a variable before you can get a value. Alright? You can initialize a variable by assigning a value to the variable at the point of declaration. Assignment happens from right to left. Right to left. So Bobby equals first name. Alright. Use single equals character as the assignment operator. To retrieve the value, use the variable's name. Nice. Alright, we can initialize. All right. Now I gotta get rid of the equal in my notes. All right. Declare implicitly typed local variables. Declare implicitly typed local variables. The C# compiler works behind the scenes to assist you as you write your code. It can interfere It can infer your variable's data types by its initialized value. In this unit, you'll learn about this feature called implicitly typed local variables. So what are they? An implicitly typed local variable is created by using the var keyword followed by a variable initialization. For example, variable message equals hello world. In this example, a string variable was created using the var keyword instead of the string keyword. The var keyword tells the C# compiler that the data type is implied by the assigned value. So it's implied. After the type is implied, the variable acts the same as if the actual data type has been used to declare it. Okay. Save on keystrokes when types are lengthy or when the type is obvious from the context. Var message. Why is the word message there? Because the variable message is immediately set to the string value hello world. Oh wait, from right to left, okay. Hello world is the message. The word message there is the I forgot what it was called. That's the declared variable. Yeah. It's a declared variable. Is immediately set to the string value hello world. So you can use var for like integers as well without typing like string int, I believe. The C# compiler understands the intent and treats every instance of message as the instance of type string. Okay. In fact, the message variable is typed to be a string and can never be changed. For example, consider the following code. Message equals hello world. Message equals decimal. If you run this code, you'll see the following error. You cannot implicitly convert decimal to string. Message equals yeah, I cannot do that. All right. Other programming languages use they use var differently. In C# variables are assigned a type by the compiler regardless of whether you use actual data type name or allow the compiler to imply the data type. In other words, the type is locked in at the same time of declaration, and therefore will never be able to hold values of a different data type. Okay. Variables using the var keyword must be initialized. It's important to understand that the var keyword is dependent of the value used to initialize the variable. If you try to use the var keyword without initializing the variable, you receive an error when you attempt to compile your code. So, var message. Oh yeah, that just looks weird. Must be initialized, huh? Explicitly typed variables must be initialized. Why use the var keyword? The var keyword has been widely adapted in C# community. It's likely that if you look at this code and examples in a book or online, you'll see the var keyword instead of the actual data type name. So it's important to understand its usage. The var keyword has an important use in C#. Many times the type of variable is obvious from its initialization. In those cases, it's simpler to use the var keyword. The var keyword can also be useful when planning the code for an application. When you begin developing a code for a task, you may not immediately know what the data type to use. Using var can help you develop your solution more dynamically. As you get started, it is recommended that you continue to use the actual data type name when you declare variables until you become more comfortable working with code. Using the data type when you declare variables will help you be purposeful as you write code. Okay. Alright, so we learned about variable. Okay. The var keyword tells the compiler to infer the data type. Tells the compiler to complete the challenge. You already know I'm ready for this, man. You already know I'm ready. In this challenge, you'll write code that will combine literal and variable values into a single message. Okay. Select all of the code, delete it. Store the following values and variables. Dude, we're locking in. All right. Should be easy peasy. These variables should be given names that reflect their purpose. Make sure you select the correct type for each variables. Finally, you'll combine the variables with literal strings. Pass into a series of console write commands to form a complete message. So write code in C# to display the following message. Oh my gosh. Hello, Bob. You have 3 messages in your inbox. The temperature is 30. Oh my gosh. All right, dude, lock in, man. Lock in. All right. Well, I'm nervous. All right, first let's set it, bro. We got a string. So string first name, and then we will initialize it immediately. Bob. All right. So right now we're just making. Okay. And then we have an integer of like lorp. Messages in your inbox, huh? Oh my gosh. Dude, I'm like nervous. I feel like I'm about to get this wrong. Because I should be okay. And then we have the temperature. Temp. Celsius. Did I even spell Celsius right? Dude, I'm so freaking scared, man. All right. So we have stored data types, I believe. Now that we have stored it, now it's time for console write line. All right. All right. Hello. First name. So we have hello first name. I think that's die. I think that's good. And then should we do console write? No. If we do console write, because we want to keep it on the same line. Wait, can we even do the exclamation mark? I'm about to test it out, dude. Nothing said I had to do it on my first try. All right, let's do this. Okay, cannot convert string into int. Hold on, wait, what? String into int. String is first name. First name is Bob. You read this, so you know that Bob equals first name. It's a string. Cannot implicitly convert type string into int. And there's two occurrences. I did say first name twice. Cannot implicitly convert type string to int. Who said Bob was a... No one said that Bob was an int. It still happened 2 times. Okay, why is Bob not initialized? String first name equals Bob. Hold on. What the fiddlesticks? So we gotta lock in, bro. String is the thing to use, right? String is what you use. Alright, what if I do this? I don't think it's gonna work, right? Okay, yeah. Wait, oh yeah, that's only one. I was thinking about the number, not the other thing. Hello, first name. Why does first name not equal Bob? Wait, yeah, you're making first name. Do I have to put in quotations? That'll be weird. Yeah, no one taught me that, bro. What did I just do? How about we just end that one? Hold on. First name. Hey, hold on. Hold on. Hold on. First name. Oh, because it has to be console right line. Oh yeah, that didn't really do much. Why the flippy does Dippy not dop? We're trying to get Bob as our first. I'm gonna look at my notes, bro. I'm gonna look at my freaking notes. So we assigned string first name equals Bob. So if I say first name, it will be Bob. It should be. Wait, no, you don't need the quotations when you do that. Hold on. That's what I did wrong. Because you put in quotations, it'll be exactly that. String. Okay. Okay, my thing is, how do I make it stay on one line? Do I just have to do this? Can I do this? They probably won't like that at all. New line in constant 1. Are you saying that you don't like this being here? You'd prefer it to be here? Whoa, now it's even worse. Okay, fine, I'll do this. Okay, that didn't work. Wait, hold on, wait, what? A comma is expected? Expected when occurrence? Oh, I get it. Okay, the problem is they didn't put it in one line. Can you put multiple stuff in one? No, you can't. Okay, hold on. How do we get it to be on one line? And doing this will be bad. What happens if you write without a line? Whoa. Hold on. I wrote without a line. Okay. And if this is here, now it will still be the... Okay, whoa, not that. If I put this here... Oh, now we're talking. All right. Hey, we have hello, Bob. Let's capitalize Bob, bro. Let's respect Bob. Hello, Bob. Welcome to class. Can I space right here just because? I can, all right. Now, can I implicitly convert string to int? What are you talking about? I have int. There is no string. I just gave you... Wait. No, I was just naming it. Oh, integers don't need... They don't need it. Can I implicitly convert float to an int? Are you missing a cast? I don't know. I don't know what we're... I don't know what we're missing, buddy. You're asking the wrong guy. So right now, this is a string because it's in quotations. And if we do this, it'll work. All right. Cannot convert double into int. I'm working with a decimal though. I'm sorry. Cannot convert decimal to int. Why? Why? Talk to me, man. What's up with that? What did it do wrong? It didn't do anything to you. And this still works. Hello, Bob. In due time. Maybe it's because we have two integers here. It can't be both. Wait. How do we make a second int? How do we declare a second one? Alright, so if we get rid of the decimal. You like that, huh? Alright, we're gonna turn that into a decimal in a second. I'm just gonna continue. You have 3 messages in your inbox. Can you do this? Oh, it's in quotations. Yeah, I guess that would be weird. All we have to do is, hello, Bob. You have 3 messages. You have 3 messages in your inbox. The temperature is... Now we just need to get that temperature, dog. It's a float, though. What do you have against floats? Like, legitimately, what? This'll turn it into a string. What about a float and decimal? Float decimal combination. They did not like that, bro. Only a song. Wait, hold on. Wait, the name M does not exist. Cannot convert float to int. Wait a minute. I thought... Oh, float. Wait, are you saying float double decimal is different than int? I don't believe that. Int is a whole number. Oh. 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 I understand it now. This is not going to work. Let's freaking go, man. Hello, Bob. You have 3 messages in your inbox. The temperature is 34.4 Celsius. Wow, we're geniuses. Like Harvard? Bro, they're tearing right now. They're so sad that I'm not there just working. Well, I did it, man. Let's freaking see it. Let's see. Alright, the following code is one possible solution for the challenge from the previous unit. I'm not gonna lie, we destroyed it. Man, we destroyed it. Okay, so string name. I guess I did make it a little harder than it had to be. Okay. Messages, okay. Alright. Wait. Oh. Look at that console right for a freaking exclamation mark, bro. Oh. Okay, what's the difference between it being F and M? Both, I guess F is like a little less. Whoa. Forgot you gotta change that to decimal. What if I don't put it? You don't like that, man. You don't like that. Okay, that does look a little bit more efficient than what I have, because I have hello. First name. You have... Yeah, I did waste a line. To simplify it. You have... The temperature is... All right. Okay. So they wrote 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. They wrote 7 lines of code. I wrote 1, 2, 3, 4, 5, 6, 7. Oh, well, now I did. Before it was 8. But yeah, that's basically like the same thing, man. Code is just one possible solution. How to create the output, for example. It's possible you could have just used more console write statements. I did actually, originally. However, you should have initialized 3 variables to store the 3 values per the instructions of the challenge. Furthermore, you should have used a variable of the type string to hold the message Bob. Yes, I did. Int for the messages, and decimal, float, or double to store the temperature. Okay? You were successful. Congratulations. I was very successful, by the way. Yes, I was, indubitably. Man. I kind of want to like put this in the example. So here we have the input. Go ahead and turns the output into hello. Can I just ignore all? Alright. Yeah, we did that, bro. Alright, now let's check. Which of the following variable names should or must be avoided? This one, bro. It's that easy. That $sign's got to get out of there. What is the problem with this line of code? Variant message. Bro, you need to initialize it. Without initializing... Yeah, man. Initialize that joint. Which of the following is the output of that? You are going to get console write line. You are going to get that's a good question. Because you didn't put it in quotations, I believe it's just going to do this. Which of the following lines of code creates a variable correctly? X equals, it's not a whole number, bro. That's not gonna cut it. I learned that before. Bool. X equals false. That's not how that works. Right? I don't think that's how that works. Wait, you didn't check me. Oh, I didn't even submit. All right, hold on. Look at that, man. Oh, you love to see that. Oh, you love to see stuff like that, bro. Awesome, man. All right. We stored and retrieved data using literal and variable values in C#. Yeah, that's actually like, it's so fun just being able to like complete something like this and say that I did it. And then the next one is going to be perform basic string formatting in C#. Dude, we're 27% done. Okay. Dude, I'm stoked for this. I really am. Ladies and gentlemen, if you like the video, make sure to like the freaking video, okay? Ooh, you know what? I want to do something. Hold on. Well, ladies and gentlemen, if you like the video, make sure to like the video. I am having quite a bit of fun completing these challenges, man. Slowly and slowly, we're learning more and more about code. And eventually, I'll be able to make my own game, bro. And that's just going to be so fun. Oh, I can't wait. Man, if you guys have anything to say, leave it down in the comments. If you have any tips, let me know as well. And yeah, if you liked the video, make sure to like the video. I think I already said that. If you want to see more videos like this, check out my playlist. And with all that being said, have a marvelous freaking day. This is so awesome. I hope to see all of you again. I love all you people.